Alright, so when we talk about limits, the limit of a function is the value that the function approaches as you get closer and closer from either side to a given x value. So let's look here. So we're trying to do the limit of 2x plus 1. So one of the easiest ways that you do a limit is you look at a picture or you like plug in a number. So if we graph 2x plus 1, it starts at 1, goes up 2 over 1. Right? So we got a pretty good picture right here. So what we're trying to look at is as x approaches 2. So as you get to this line right here, so as you get closer and closer to x equals 2, what is happening to your graph? So the graph, as you get closer and closer to 2, so you're coming in, your graph is getting closer and closer to a height of 6, or 5, that is, sorry. So the answer would be 5. Now in the simplest of cases, you can literally just plug 2 in here. It's just like an evaluation problem, like 2 times 2 plus 1 is 5, right? So basically what's happening is the limit is the intended height, the y value, of a function at a certain x value. Okay? So look, it's the intended height, it's not the actual answer all the time. So for instance, on a graph like this, we got a piecewise function. We have like a cubic function, and then we have a line. So the value of this function at 4 is this spot down here. It's -5. But the limit at 4 is not -5. It is, remember, so for all intents and purposes, this function, it was like going like this and coming to here. It was coming to here. It was coming to -2. And that is the value of the limit. It was the intended height, where you were supposed to be. And, you know, they can't help that you jump down to here. So it doesn't have to match the value of the function. And over here, f of -1, so it means at -1, where is like the blackness of the graph, and it's here, at -1 is 1. Now the limit as you go to -1, now I'm going to do these other two first. So if you go to -1, this little negative sign means from the left. So if I'm coming to -1 from the left, so from the left I'm approaching a height of 1, whereas from the right I'm coming around, I'm approaching a height of 3. And you see how that doesn't match? Like, neither one is more important than the other. If your left side and your right side do not agree, then you put here, does not exist. So there's no solution for that limit, does not exist. And so we use the letters D and E when we want to say does not exist. Okay. All right, so remember all piecewise functions, you had them up there a little bit, so now we're going to graph on ourselves. So if somebody wanted me to find f of 2 in this problem, I would go to the problem where it was equal to 2, so this means I should plug 2 into this problem. So 2 squared is 4, 4 minus 3 is 1. Now, if I want to see if the limit exists, I have to make sure that they were both going to meet up there, they were both going to meet up and not be like a gap like this. So even though I'm not supposed to plug 2 into this problem, I plug it in just real quick to see if it matches the other one. So if you plug 2 into here, 2 minus 1 is also 1, so they would match right there. So basically what would happen is there would be a hole, so there would be like x minus 1 is this graph, so it starts at -1, it goes up 1 over 1, so it goes to here, but at 2 it doesn't exist there, so that graph goes back like this. And then everything after 2, you have your parabola graph, so your parabola starts at -3 and goes up like that, so it goes over 1 up 1, over 2 up 4, and then it just like keeps going up like a parabola there, you know, 3, 9, and so forth. So it acts like a parabola the rest of the way. But what happens is that this comes and it like fills in the hole from the other guy. So you have like a line and then a parabola, but there's no gap. There's no like gap like this, and there's no empty whole or anything like that. Okay, let's do this. So just some basic limits. This is like a nice continuous function right here. So this is a cubic function, and you don't have to make a graph. If there's no problem plugging in 1, then just plug in 1. So 1 to the third is 1. So 2 minus 4 will be negative 2. So basically it's telling you that at 1 the answer is negative 2, right? The intended height of the function. All right, over here we got a cube root function. If there's no problem plugging in 5, I just plug in 5. So my cube root of 2 times 5 is 10 minus 2. Cube root of 8, well, that's 2. Right? And over here, the limit of a constant. So remember, this is f of x right here. If you graph y equals 2, it's just going to be like this, right? So no matter where you are, the answer is always 2. So the limit of a constant is that constant. It's the same anywhere. So any number you plug in, you always get 2 because there's nothing to change the 2. All right, so let's move on to here. So in some of these problems, when you get to do a limit, you get something undefined. So when I try to go plug in 3 here, I'm like, oh, well, 3 minus 3 on the bottom is 0. That's an issue. On the top, I get 9 times 2, I get 18. Minus 6 times 3 is 18 also, so I get 0 again. So this is indeterminate, like you don't know what this is. But a little bit of factoring, so this limit will turn into the limit as x goes to 3. And you go ahead and do some factoring. You take out a 2x here, which will leave you with the x minus 3. And then x minus 3 again, so these cancel. So what's happening is there's a hole at 3, but the intended height of the function is still 3 plugged into here, because look at the table here. As I get closer and closer to 3, my answer is undefined, but you see these answers, like if I estimate here, this is 5.99, this is just over 6, it's probably 6, because when I plug 3 into there, I do get 6. So this turns into the limit as x goes to 3 of 2x, and 2 times 3 is 6. So it has a limit even though there's a hole in the graph. So you might have to do some factoring. So in fact here also, negative 4 plugged into here gives me 0 on top. Negative 4 plugged into here gives me 16 minus 4, which is 12. 12 minus 12 is 0. So I'm going to factor. So I have to write limit. X goes to negative 4. Let's do x plus 4 and x minus 4. And the bottom, we get x plus 4 and x minus 3. So that's gone. And now that was like the offending part. That was the part that was causing the zeros on the top and the bottom. So let's plug negative 4 into this. So negative 4 minus 4 is negative 8. And negative 4 minus 3 is negative 7. So my answer is 8/7. Okay. All right. So now we're going to get into some limits that go to infinity. So whenever you have an asymptote and you're approaching the asymptote from one side or the other, you might go to infinity. So let's do 3 from the left. So as you get closer and closer to this vertical asymptote from the left, you're going up to positive infinity. And I know it seems like, oh, infinity has no limit, but you still just put it. 3 from the right is negative infinity. So 3 altogether would not exist because these answers are a mismatch. So this is DNE. Whereas over here, when approaching 3 from the left and the right, these are both going up to positive infinity. So 3 overall is also positive infinity. All right, so now you have these crazy pictures here, and so we're just going to use this picture to do all these limits and function values. So f of negative 2. Negative 2, I have to go where the blackness is, so this part right here, so that would be 3. My limit at negative 2, though, is down here. It's negative 4, because that was where the function was intending us to go. All right, 1 from the left, so 1 from the left, even though it's empty there, the limit is still from the left is still 2. 1 from the right is 0, my height. So 1 overall, mismatch, so it does not exist. F of 1, so look, there is no blackness there at 1, so this one does not exist, or undefined. And f of 4, I go here, the answer is 4. So just little quick facts about a picture. All right, so more with limits from the left and the right. So if I'm doing this problem here, f of 1. So 1, if I'm using 1, I'm supposed to plug into this equation, so I get negative 1 plus 5, so that's 4. All right, now my limit from the left and from the right. So from the left of 1, oh, sorry, these should say 1s right here. These should all be 1s right there. So from the left of 1, I'm going to be using this problem, right? Because these are numbers to the left of 1. So if I'm doing the left, I'm going to approach, negative 1 plus 5, that's going to be 4. But from the right of 1, I'd be using these numbers, so I'd be putting a 1 into here, so I'd get 6, and these do not agree, so there's going to be a mismatch. So if you were to graph that, everything to the left of 1 is using negative x plus 5. So you start at 5, go down 1 over 1, and so that's that line right there to the left of 1. And to the right of 1, we're using 2x plus 4. So 2x plus 4 starts at 4, goes up 2 over 1. So there's the empty spot, and then up 2 over 1. So it would go off like that. So you see that gap right there. That's why you get a does not exist limit for this full limit here. All right, so moving on, almost done here. This is just another picture to practice this. So maybe pause the video and, practice this a little bit, and then come back and check the answers. So f of negative 4 is 1. The limit as you go to 1, so as you come to 1, it approaches a height of 3, not there. That would be f of 1. F of 1 is 1. F of 0 is 2. What's the limit of negative 4 from the left? So negative 4 from the left is a height of 1. Negative 4 from the right is a height of negative 2, so those don't match, so it does not exist for the whole limit. Alright, so now we're going to do some limits where you're approaching positive or negative infinity. So this means looking at the far right or the far left of a graph. Okay, so we're basically looking at the end behavior. So when you have a rational function, your end behavior has to do with the horizontal asymptote. So remember the horizontal asymptote rules. When these degrees match, your horizontal asymptote is y equals 3. So as you go to the right, this graph is going to come down to 3. Also to the left, same thing, but it approaches 3. Okay, even though you can't really plug in infinity. Okay. All right, so down here, as you approach infinity, it's a rational function, so we need the horizontal asymptote. So my horizontal asymptote here is y equals, remember, when the top is smaller than the bottom, that's y equals 0, so it's going to approach 0. Again, these match, so this is going to approach 1/3. And this guy, the top is smaller than the bottom, so that's going to approach 0. So also remember there's problems where you have a slant asymptote. So like if you had 4x to the third plus 2x squared minus 1 over 2x squared minus 3x plus 5, and you're doing the limit as x goes to infinity, right? So look, this is a slant asymptote. The top is bigger than the bottom. A slant asymptote with the positive leading coefficient. So a line with a positive slope, as you go to the right is going to rise, left is going to fall. So this answer of positive infinity would be infinity. If this was negative infinity, that would be negative. And if this was negative, the line would be going the other way. So your answers would be opposite. All right, these last two, just dealing with end behavior. So sometimes your best thing to do, like you can't plug in infinity, so you're gonna think of a graph. 2 to the x plus 3, that's an exponential growth problem. It's moved 3 up. So that means that there has a horizontal asymptote of y equals 3. So as you go to negative infinity, the graph approaches negative 3, and that's what you're being asked here. But if I was going to positive infinity, it would approach positive infinity. All right. Natural log of 4 minus x, so there's an asymptote here of at x equals 4. So as I go to the left, this graph goes up, 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 up. So positive infinity. Okay, so just be able to draw a little picture. All right, this guy down here, this is the square root function. So a normal square root function looks like this, but this one has been flipped over the x-axis and moved to the right 3. So it kind of looks like that. So as I go to infinity, so as I go to the right, this graph keeps getting lower, so negative infinity. So you have to be able to draw a little picture. All right, e to the x. E is a number bigger than 1, so this is just exponential growth. So exponential growth, as I go to the right, it goes up. As I go to the left, it comes down to its horizontal asymptote of 0. Okay, and that's it.